I'm repurposing part of a 20-year-old presentation, and also I've added some new things and kind of mixed some things together. Never done this particular version of it before, so we'll see how we do on time. You get a prize if you can name all 4 people who are pictured on this slide. Norm, you want to take a...
Jeff, Dr. T, Alex Davern, and... Not Alex Davern.
Wrong. You're wrong.
Tim Jeffries, and... Can't tell them. Yeah, it's all the work.
Anybody else? Anybody else? Nobody else wants to take an attempt? Okay. The prize, by the way, is that you were going to get a hug from Norm. So, you know, I guess give yourself a consolation hug, Norm. Okay, that's so this was NITech was an internal R&D conference, and they still do them, but this one was from 2002, and it's Jeff, Dr. T, Bill Nowlin, and Tim Denny, who was VP of R&D. So 3 founders and then the VP of R&D. And so now what is the Lord of the Triangles? Who remembers the triangles? Who can name all 4 triangles? Let's go with a non-NI employee. Let's go. Go ahead.
Oh, we're both NI employees. Or we were trying to.
Well, let's do it anyway.
Employee success, shareholder success, customer success.
So shareholder success, employee success, customer success. There's a bunch of them in this room. Supplier success, which includes partners. Right. So you can get a hug from Norm. And, yeah. How many of those do NI still use? 0. They don't actually use triangles anymore. Okay. So this is about terrible LabVIEW API design. So originally it was about good LabVIEW API design and trying to teach people inside of NI how to write better APIs instead of what they were doing instead. But you know, there's so many good examples of bad APIs that I just decided to turn it into that kind of presentation. But I'm going to start with Our Giants Are Female. And I just picked one at random. I do a lot of work at Los Alamos and Sandia. Dr. Harshini Mukundan is a biomedical scientist with appointments at Los Alamos and Lawrence Berkeley National Lab. She's born in Chennai, bachelor's in Delhi, and then her PhD at the University of New Mexico School of Medicine. And one of the many things she's done that's really cool is her team has created a universal bacterial sensor. And so, like, you know, if you have sepsis, they, you know, start to take a culture, takes, you know, up to like 14 hours to do some of these cultures. And this is a new kind of sensor where you don't have to do the culture and it can actually detect and identify many different kinds of bacteria in just a matter of minutes. So it's really cool and would really speed up the potential for healthcare in an emergency setting. So anyway, just wanted to highlight her. Okay, what are some examples of it? How would you define a terrible API? Because you've probably seen some.
Modulation toolkit.
Yeah. What about it makes it terrible?
It's very difficult to create a good-looking and easy-to-follow flow of the program.
So hard to create a good-looking modular version of a program. What about it makes it that way? It's like too many icons, not enough icons, putting the icons together, they don't fit quite right. What about it?
Simply what I think I would say, it was not created from kind of a session-based perspective. And so there ends up being a lot of shared information that you have to re-replicate the data flow from nugget to nugget to nugget, which tends to lead to a pretty wire heavy replicated you're chasing out where sources of information are on a typical example and things of that nature. So it would have maybe benefited from creating a session to do the algorithm to hold the common information downstream.
Yeah.
That was not good.
Yeah, so lots of things that make it kind of LabVIEW unfriendly. Yep. What are some other examples of, yes?
You wouldn't think this would ever happen, but pop-up dialogues.
Pop-up dialogues. So in the middle of, hey, I'm running my continuous acquisition and logging loop. It's supposed to run 24/7. And look, it's just letting you know something happened. And please enter your, please confirm that you're still here by entering your password. Yeah, right here.
I would say grouping together dissimilar functionality. Oh, hey, the microphone. I would say grouping together dissimilar functionality that doesn't belong together and not making things granular enough.
Yeah, we'll get into that.
Which drives me crazy.
Yeah, we'll get into that. Sergio, you had over here. I'm making my microphone people work really hard today. That's good.
I gotta get my steps on.
One that has hidden features that you only know about or your group, and you think that that's the way of doing it. They are undocumented, and suddenly somebody is asking questions about them.
Yeah, undocumented features. Yeah, I've hit some of those. Yeah, how do I do this thing that's undocumented in this other API? Yeah.
In the case of LabVIEW, when they're buried in some obscure place, like they don't have a palette, they're not in VI Lib, they're not in instrument.lib, they're just sort of living in some place that you have to go find after you install it.
Yep. Hidden places. One more.
Not using standard Windows functionality, like make the darn red X work to exit your program.
Say that last part again?
Make the darn red X in the upper right corner of your program exit the program, just like every other Windows program in the universe.
Yep. Okay. So those are all good ones. I kind of summarized it this way, unintuitive and unlearnable, the learnability of an API, like we saw with iMac yesterday. The way you learn it apparently is to run VB for the what was it? Something for AI, Visual Builder for AI, and then the iMac Assistant or Vision Assistant. That's how you learn it apparently, and not through the palettes where there's just a whole bunch of icons that look like they're relevant, but it's not clear how to put them together. Fabiola. Wait. People can't hear you, Fabiola. You need to.
You think that they cannot hear me?
The video recording.
Okay, that's a different one. All right. A terrible API would be that they not taking into consideration your audience, your target audience. So if you are using the geeky language for high school students, they may not be introduced to that language. And on the reverse token, if you're doing a high specialized API for chemical engineers, you probably want to use the language that's they're familiar for them.
Yeah, and we'll get into later, how do I build an API that works for the simple use cases and works for the complex use cases? So we'll talk about some of that. Let's see, inconsistent with itself and other APIs, we've talked about that one, and then unusable for both simple and advanced. So, originally this presentation had the more positive statement, but I just changed it all to negative. Okay, so here's my agenda. I'm going to talk about some easy stuff, some intermediate stuff, and some advanced stuff. The easy stuff, probably for a lot of you, it's going to be like, you already know this stuff. But I just want to go through it because, GDevCon is not just for CLAs, it's for everybody who's on their LabVIEW journey. Then we'll talk, so that's going to be a lot about inconsistency. Then we'll talk about layered APIs, how to build something that works for easy and advanced. And then there's some probably more provocative stuff I'll say about the abuse of interfaces in this weird class hierarchy section at the end. And so we'll see how that all works. Okay, for part one, those of you who know me know I'm not normally sarcastic, but for this presentation, I'm going to be sarcastic. So just in case somebody takes me too literally, this first section, do the exact opposite of everything I say. Okay. So first, pick terrible connector panes and wire them in random locations. Have wires coming in from the right. Make sure that they don't line up when you put them all together. Use as many of these different connector patterns as you possibly can in your API, right? So that just to show that you can, just to show how clever you are. Who remembers what the last few connector patterns are called?
Do not use the ones.
Do not use. Well, that's one thing. So
Especially the asynchronous.
I think it's Darren, you were going to say it, but I think it's let's see. So this is, I think, the Monty pleaser. So Monty Anderson, the late Monty Anderson, he passed away less than a year ago, probably, earlier this year, I think. He was like the first QA guy. He had a lot of industry experience and brought it to NI. He was one of the first NI employees. And we used to have these great philosophical discussions about, it always start with him asking, why does LabVIEW do something, right? And he'd go off on these various philosophical things that generally it caused us to improve LabVIEW in some way. He's also the guy who discovered that uninitialized shift registers acted as global variables. We didn't intend it for it to do that. He just discovered that it did, and then he discovered a way to use it. And so then it was a feature from then on. We couldn't actually remove the behavior because Monty thought it was useful. So anyway, Monty liked to use a lot of connectors instead of clusters. We eventually cured him of that. But we created this one that has like 5 on the left, 5 on the right, and 6 in the middle. They called it the Monty pleaser, because please Monty by adding a bigger connector plane. Then we added another one after that called the super Monty pleaser. And that has even more. And then after Monty left NI, he retired, soon after NI went public. And but we added another one, and we called it the Monty would be pleaseder. So, okay. Oh yeah, be sure. So it used to be that LabVIEW, when you showed the connector pane for the first time, just a moment, hold your horses. Okay. It used to be that LabVIEW defaulted to the connector pattern that matched the number of controls and indicators that you had. So if you had one indicator on your front panel and you said show connector pane, then it would immediately select that first one because one input, or one IO point was what matched that best. And if you had 3, then it would pick that second one, and so on. And so it was Rob Humfeld did his 10 Things I Hate About LabVIEW in 109 week. And that was one of the things he complained about. Is like, my standard is to use the, where is it? This one, 4224. Like that's the one I prefer, most people prefer. And he said, why doesn't LabVIEW just do that? So that evening after NI week, I went back to the LabVIEW team and I actually changed it so that this is default. And then I didn't tell anybody that I did that because I didn't get an approval, but I got in a little bit of trouble from the internals, but all of y'all were much happier, so. Let's see. There was a question over here somewhere. Steve. Jörg.
Are you ready?
Yes.
Is it now a good time to ask a question, Brian?
As good as any.
Thank you so much.
You're looking very nice today, Jörg. Is that freshly pressed?
You bet it is.
All right, thank you, Jörg. Steve, did you have a question?
I was just going to ask, is there anybody else with a white shirt here today? No, that's not my question. I was wondering, why did you add the last one? bottom right one, the money would be pleaser.
Why did
you
we
remember?
add the money would be pleased? I really don't know.
Because they could. Right.
Yes, I guess they decided like that we're getting all these requests for more, so let's make them as small as possible and see how many we can fit in. So they'll just be quiet.
They had an empty spot.
It's like every wire goes into that function. So it's like, I don't even know anything about LabVIEW. If I look at it, I'm like, I know that thing's important.
So I've got a group name for that bottom area, which is the I Laugh in the Face of Cohesion collection.
That's right. Yes. Yeah, this is a good way to build a lot of cohesion into your APIs. All right. We're running behind schedule, but I think we're entertained, which is the important thing. That's why we're here. Let's see. So front panel as both a user interface and an API. So be sure and use Boolean text for documentation. So we see we've got a Boolean, rising edge, falling edge. Okay, now what is the answer here for false here? Does anybody remember? What's rising, what's falling? And so that's where you have to actually go back to the front panel and see that, oh, it's falling is what false means. And so be sure and do that a lot. Whatever you do, don't use something as self-documenting like a ring, because that means that you don't have to switch back and forth. Okay, planning for change and like level mode of percent and waveform units, that's good enough for anybody, for all APIs, for all times. So just use a Boolean for that, right? As opposed to a ring, which you might be able to add more things to later. Fabiola.
I should just stay over here.
You probably should just stay over here. No. One example of this is also thinking that not because you think that there's only yes and no. Remember that your boss can always come and ask for maybe. You are coding software, and my example of this, I was doing a form for a hospital, and it was all the vertebra to determine spinal cord injury. And I was like, oh, of course that's never going to change, right? We all have the same vertebra. Yeah, but I was doing a form, not a human being. So we needed not applicable, indeterminate, in between, like all these other options that they added afterwards. So even if you think you have all the possible options, it's better to do something that will allow you to add more.
That's right. It's just like TTL signals are just high and low, right? There's no idea of tri-state or higher than high or lower than low or things like that. So yeah, here's another example. Okay, names. Be sure and use terse names that you know and nobody else really understands. So, mode. I see a lot of APIs that say mode. Hope you know what mode they're talking about. CH for channel, or maybe Switzerland or something. Level. Like level is another favorite of like, well, the level of what? Is that a voltage level? Is it an engineering unit level? It'd be nice to know. Unclear sense of Booleans, so like polarity true, we already saw something like that. And then, we also see lots of reverse logic. And just to prove that NI still can make mistakes or implement things in a clever way, even today, Darren tweeted something, or somewhere you posted something about like, why does lookin, map, and element of set, which were two features introduced at the same time by, I believe, the same developer, right?
Yes.
Let's just say he was an active framework guy. And one of them has true means found, and one of them means true means not found.
And his name includes a Q and it's not Q.
So anyway, be sure and use a lot of that too. That's everybody loves when you do that. Let's see. Old instrument drivers often did this thing on the top of where, like, I'd see the application and it looked like channel 1 is wired into every one of these things. I said, why do I need 4 copies of it? Why don't I just have one channel 1 and wire it into all of them? And then I realized, when it didn't work, I realized it's because all those rings are different. right? So channel 1 actually had the value 1 for color, but had the value 0 for the others.
It gets worse. One of them is it's an ego, and the other one's a ring.
Yeah. That's right. Yeah. That's right. So this is one of the few cases where I actually like using strings instead of enums for this stuff. Because I don't really want to make the super enum that I could wire into any of these functions, because I really want the guidance of, of knowing what is allowed. But this is one of those few cases where I would actually prefer to use a string and use something like ch1 and wire it into this Tektronix scope API. Does anybody disagree with that? Okay, yeah, kinda. Yeah, it kind of makes you want to disagree with it, but this was the best compromise we came up with. Because ch1, it's relatively straightforward. But then, yeah, on some of these other ones, it may not be as intuitive. So, yes. Can anybody think of a way to address that? Oh, we'll come back to that right after this.
Is that Switzerland one?
Yes. Yeah. So what's in a way where you could maybe do the thing on the top, but still make it so you could wire the thing into any of these functions if you wanted to?
An enum, and then you disable options for each one. That doesn't make sense. So you do a super enum with disable.
Oh, so force them to wire the right thing into it with a strict type def thing?
Yeah.
That's one approach. Another approach, which I don't really recommend, but it would work, is you make each one of these a sparse ring, meaning the value, for example, maybe well, actually there's two ways. The better way, well, one was a sparse ring where you just come up with, channel 1 always maps to 0, or maybe channel 1 always maps to 1 is probably a more intuitive thing. And even in this one color case, you make sure that channel 1 still maps to 1, that all the other ones, channel 1 maps to 1. So that's one approach. The other is you make it I forget what you call it, but where the value is a string. And so you have one like this, but its value is ch1. And you could have that actually passes that string into the combo box. That's what it's called. So many different things. There's a question.
I was going to suggest you could probably have a scan from string and convert into your ring or enum before passing it in. That at least gives you a bit of an error check of if you have an invalid string.
Yep. All right, let's move on. Okay, this is a slide I added yesterday when I was thinking about the IMAC thing, and I don't think IMAC uses the dynamic data type, but it really made, the idea of ExpressVI started, the dynamic data type. So I call this the DDT for multiple reasons. Anybody want to explain what the dynamic data type is?
I'll probably trip and fall, and it'll be fun.
Bad.
That is correct. What makes it bad?
It's totally indeterminate what is actually on that wire. You have no idea, and I forgot. I haven't used it in forever, so I don't remember what probing it does. But all you can see right here, all the little red conversion dots are doing the best job they can. There's a lot of heavy lifting on those conversion dots.
Yes, this data type was added in LabVIEW 7 Express. Who remembers LabVIEW 7 Express? Right, came after LabVIEW 6i. LabVIEW 7 Express was when ExpressVIs were introduced, and it was supposed to be, let's make LabVIEW use as few icons as possible to do applications. This was back when they were competing with HPV, which put out some sort of, sample program that used fewer icons than LabVIEW did. And so somebody up the management chain decided we also needed to reduce the number of icons, and so LabVIEW 7 Express came out of that. One of the things that came out of that was we needed this universal data type that can be just about anything. And I really fought against that. And it's one of those many cases where I fought against something and I was right, even though I lost the argument. So, yeah, that's kind of my career at NICE.
We love you, Brian.
Yeah. So I remember having a conversation with Dr. T about whether I should buy HiQ, and I was opposed to it, and he was for it, and I was right, and he was wrong, but we bought it anyway. Okay, so in fact, Jörg and I last night were trying to figure out exactly like some of these. So okay, here's actually first question: internally, what is the dynamic data type? Does anybody know how it's internally encoded? What?
It's an array of waveforms.
That's right, it's an array of waveforms. Ooh. So it can have a waveform is a T0, delta T, and an array of values, like scalar values. And then I can have multi-channel version of it, where I have an array of those waveforms. But again, the intent of the DDT is it can encode anything. So if you have an array of waveforms coming out and you wire it to numeric, it takes the last element of the first waveform as the value that you get out of there.
Oh my goodness.
If you wire it to a waveform chart, you get the whole array of waveforms thing. If you add it to 5 in this case, you're adding the last element of the first waveform to 5, and then that's what you get on the front panel. What do you get if you wire it to a Boolean? Who wants to guess? This is where you're gonna what is it doing? Okay, do you definitively know, or are you gonna guess?
No, I have a different question.
Okay, we'll get to it in a second. Anybody know?
No, I'm gonna guess.
Is it an empty array of waveforms and an array with one element in it? Because that would be.
Is wiring it to a Boolean?
Yeah, so if it's an empty array of waveforms, it's a false.
No, that's no.
I actually got this in a customer application that I inherited. I still don't know what it does.
So Jörg's and my conjecture is that it takes the last element of the first waveform, and if it is greater than 0.5, it is true, and if it is negative or less than 0.5, it is false. So be sure and start using this all over your application. Your customers are going to love it. Okay, there were several comments and questions here. Let's start here.
So the top one doesn't actually do that to the last element. It only does that when it pulls it out in the last numeric, right? Because the +5 on the dynamic data will just add 5 to every element there. And then you're pulling out the last element when it goes into that indicator.
You are right. You are right. But when I did create constant on the input to the add, it created a scalar.
Yeah.
Yeah.
Wait,
right here.
When did it create the scalar?
When I did create constant on where the 5 is, it created that scalar, not another waveform.
Right. Yeah.
I just wanted to venture a guess that maybe DDT might stand for don't do that.
Yes. Yes. It's also been outlawed in the United States since the 1970s. Okay, was there another one before we go to FOB? The FOB is Fabiola has something to say. I know you're shocked.
No, I was only going to say that Nate had the right answer, so he wins a Norm's hugs too, right?
You get
so
another
now
hug from
he
Norm.
gets 2.
All right, icons. Even though I normally follow Darren's advice to just put text on icons just so I have something there, why not make it a really weird font that doesn't, that's illegible? And if you can combine that with a picture that's illegible, that's a great added bonus. If you'd like some culturally specific icons from Mexico, then you've got your person right here. I recommend the mole, the chicken mole and the chicken tinga. All right. Okay. We're going to move on to phase 2 where it's not as sarcastic as that. There still might be some sarcasm that I leak in. Okay. This presentation, or at least this part of this presentation, was originally written when we were transitioning from traditional DAC to DAC MX. Who used traditional DAC? Wow. Half the room used traditional DAC. It had a lot of interesting traits to it. One of my favorites was, I think it was AI config or maybe counter config, where you had like here's essentially the enum of all the things that you could configure. And here's I think it was a cluster of 2 numerics. And what those 2 numerics meant depended on which of the things you were trying to set. So you might be setting a range. You might just be setting a initial voltage. So you really had to study the documentation to figure out how the API worked. Another thing that we harped on a lot is that traditional DAC had easy, intermediate, and advanced VIs. And the general recommendation from anybody would be just use the intermediate ones. They can do everything you need. But people like to start with the easy stuff because it seemed a lot simpler. Fewer icons, and if I'm just going to acquire a voltage or something like that, it's a lot easier to get started with. The problem was that if I wanted to say add a digital trigger to my analog input, there's no way to do that with this icon. You couldn't add some other icon in front of it. You couldn't configure anything. You had to throw away this code and then rewrite your application this way. Right, so this is an example of what DACMX we really wanted to fix. How do we make it a single DACMX API that works for easy and intermediate and advanced APIs? Yeah, so we call that incompatible layers. So one of the goals that we achieved on this is you start with, I want to acquire an AI voltage channel and acquire a waveform from it, 1 channel in samples. And if I want to add a digital trigger to it, I just insert an icon right here, right? I don't have to rewrite anything. I just insert my trigger, or there's various other things that I can insert in there. If I want to change my timing, for example, I can change it there. If I want to change my buffer sizes, I can just insert more icons in here without having to throw things away. All right, so anyway, when you build your APIs, think about how you can somehow do this. It does tend to, notice here, there's not really this concept of a session, there's just concept of channels. That's when in DACMX we introduced this concept of the DAC task, which is that and that. And it's the task that starts to collect this information about timing and triggering and buffer sizes and stuff like that that allows us to accumulate that as we continue through these icons. Make sense? There's another variation on this where we'll talk about property nodes. So one of the ways that we do the advanced stuff, the really advanced stuff in DACMX is you can get to individual properties of the DAC boards and DAC channels that you've got. So for example, configure serial port, has all these different things, most of which you probably don't care about. And so, how do you make it so that the average user doesn't have to think about everything? And so, if you go to property nodes, if I only care about one of these, then I only have to show that one property and change, like serial stop bits or something like that, right? It's the same with the DACMX. Maybe I took out the picture of the DACMX API, but the DACMX API also uses property nodes for the more advanced things so that we don't have to fit them onto some icon with 28 inputs and outputs in order to make sure that you can set something. So the property nodes is a much more extensible way of, I can pick and choose what I want to set or get and just use a property node to do it. It doesn't have to be in an icon. Another thing we did, I also thought about this yesterday during the IMAC presentation, is that we changed how we organized the palettes when we introduced DACMX. And also with LabVIEW 5 and LabVIEW 6, we changed how the VISA palette works. This is the LabVIEW 5 VISA palette, which has most of the VISA API in it, but then you've even got some more other things here for events and stuff like that over here. But really, most people who use, actually you see at the very top, those are the easy functions, and then you've got the advanced functions here. It's in LabVIEW 6, we rewrote VISA to just have one API that could work for everybody. And so we also realized most people start with Visa Write and then they follow it with Visa Read. So just put those icons at the very beginning of the palette menu and make those easy to find, make the less common ones on the next row and the less common ones after that go into that sub palette right there. We also made it so you didn't have to use Visa Open and Visa Close. We magically opened and closed the Visa sessions because we had a Visa, essentially like a DAC task, a Visa session that could track all this stuff. There was a question, I think, somewhere, was there? Okay. Okay. Last few minutes, and then we'll have questions. So, a story about abusing interfaces. Who knows what interfaces are? All right. Who wants to describe an interface? Who wants to? Somebody, Adam, describe an interface.
So it's an abstract list of methods, essentially, that can be implemented by classes that also have other parents. So it can sort of span a class hierarchy, and multiple classes can implement it, and it doesn't demand anything other than what that interface, what that list of methods is.
Yep, that's accurate. We'll get into an example of that. So anyway, I was working at this customer site. The customer is not here. The customer is also unnamed. It was written by a friend of mine, a guy I know. And I respect his abilities. He's actually not a bad LabVIEW programmer. But he came to LabVIEW from the ActiveX world. And in ActiveX, there's a object model called COM, or DCOM is another variation of that. Component object model, and it is what I would call like pure interface-based programming. So every class, every object has interfaces only. And the interfaces all inherit from a generic interface called IUnknown. And from IUnknown, you can go and query to see what other interfaces exist, and there's versioning. And then once you find another interface, then I can figure out how do I talk to that. And so it's a very discoverable thing. So if you have an IDE like Visual Studio, then it can go and query these things. And just like in LabVIEW, when you use the ActiveX node, you tell it what object you want to look, it tells you what interfaces it has, and that tells you how to program it, right? It's great. But that interface-based idea, it's like, okay, implement that in LabVIEW, but do it in LabVIEW 2016 where there are no interfaces. Right? That's where things start to come apart, in my view. This is my humble opinion about this particular API. So first of all, this is how I think this is a good use of interfaces. So I have something like a magical device that can behave like 4 different things. It can behave like a DMM or a scope or a spectrum analyzer or an arbitrary waveform generator. I don't really want to confuse my DMM API with a bunch of RF spec-in functions, or vice versa, right? I'm either treating it like a DMM or I'm treating it like an. And even if I'm using both, then I want to program it with maybe 2 different connections to the object. And do it that way. But there's one object, there's one class, there's one like physical, in this case DLL that's behind this thing that implements those 4 interfaces, right? So that is what I would describe as a good use of interfaces. Like that makes sense, right? This is the class hierarchy of the customer application. It magically made itself so small you can't really tell what anything is. And it's not inherently bad, but I'll just describe what's really the 3rd layer of icons that's kind of in the middle there, that's relatively sparse, but you see it kind of scattered all the way through. Those are the interface classes. And so, like, for example, there is an emergency stop class. And then from the emergency stop, there's I have my simulated emergency stop. I have this flavor of emergency stop button, as I have this flavor of emergency stop. And those are the next layer down. That's the really thick version of the implementation classes of the interfaces. And so even though it's written in LabVIEW 2016 without interfaces, those interface classes are written as just generic parent classes, but they have no data in their controls. And they should never be called themselves, right? The intent is you will always inherit from these things. I guess it probably enforces that with the checkbox. But the problem is, in my view, you see that thick row of the implementation classes? A lot of those would be the magical device that implements several of these interfaces, but because the way they implemented it, there's a whole bunch of really, really small implementation classes. That's where the data is, that's where a lot of the logic is, that in my view, I would have just done in the parent class. I would have actually done something in the parent class instead of using an interface to it, right? And so then it's, that's what really made me think of like, when would I use an interface versus when would I use a parent class, right? Again, this is not inherently bad, I just don't like the way this works. So I looked at, one of the best examples of like, when do you make this decision actually came from Microsoft. And so if you go into MSDN, if you dig around in it enough, you'll find this recommendation. So if you anticipate creating multiple versions of your component, such as multiple kinds of emergency stop, create an abstract class. Abstract classes provide a simple and easy way to version your components. If the functionality you're creating will be useful across a wide range of disparate objects, use an interface. And so that goes back to the, if I have a whole bunch of different kinds of magical devices that some of them pretend to be a DMM, and some of them pretend to, be an ARB, and some of them don't implement all these things, and some do, some implement even more. That's where you use interfaces, and you have a small number of that fourth row there instead of that being your biggest row, right? So then continuing that, abstract classes should be used primarily for objects that are closely related, whereas interfaces are best suited for providing common functionality to unrelated classes. Right. Discuss. What do you think of this? What would you do? How many have done it that way?
Intentionally or unintentionally?
Expand on that, Alan. Wait for the microphone.
I can see, people I won't name who might be sitting right here holding this microphone. I can see somebody starting not realizing they were going to end up here. And it's an easy mistake to make. And it would call for, some rather painful refactoring, which you probably should. It's that design's tricky.
Yeah. How might you refactor in a way that starts to chip away at this? Which I know is hard to do in the abstract, but
really hard to do in the abstract. I'll share a thought that I had, and it goes back to you're putting stuff in the base class. You can either pull that base class functionality out, and then it becomes something you provide to all of these subclasses, right? So they just become wrappers around something else. Might be something that I might try. You might also try the base class with everything that's important is a protected method, and then you just call the specific stuff that you want. You use the subclasses to expose, the wrappers around just the components you care about.
So basically, to summarize, I think, start moving some of that stuff to that interface class and turn it into a parent class that helps take the load off of some of those child classes.
Yeah, I think so. That or you pull it out so that you have I have the class that's the instrument, and these are just different protection proxies essentially around it that just expose the things that we care about. Might be another way to go. I don't know. I'd have to look at the particulars.
Yep. There's another comment back, Norman.
My instinct on this is a little bit, what's the user being exposed to as the very first what to do? Because if this is what facilitates the under the hood enough, as much as I hate it, not necessarily even that I hate it, but is the user exposed to, I need to pull out this interface, I need to pull out this object, which pulls out an object, which begets an object, which begets an object.
Just to answer your question, just to see if it informs anything, and this is another problem with this application. So this is a machine that has lots of different options, and you identify in the INI file at launch time which of these implementation classes that you stick into one of the top level classes, like, okay, this is going to be your emergency stop object, but it's not dynamically loaded. It actually hard codes in the case structure of like, oh, pick this object versus that object versus that object, and so it's trying to be configurable, like one version of the software that can run with a bunch of different machines. Does that help or make it worse?
It brings up a different topic in my brain, which I'm trying to corral all the kittens as it is. But I would say if we're trying to structure the inner guts of the thing to allow it to do multiple parts of it, I think part of the discussion that hasn't been part of this is composition of the objects inside of it. And as opposed to relying on the class and that structure for facilitating all of the actions and activities by virtue of, hey, what am I? As opposed to, hey, I contain a thing inside the guts of me that I give the user a nice clean interface through whichever means makes sense for that end user, but then inside the guts of it, I'm composing that thing of maybe those multiple different parts and pieces. And interfaces might allow me to have a palette or an API that gives the user an easier ability to just drop nodes on a single reference, right? My magic thing has just that handle, but now I can drop those different functionality items on that same handle. And so that's what the interfaces at that top level provide, but down inside the guts of it, maybe you're not necessarily relying on the interface implementation to fulfill that. You're using composition of objects inside the guts of it to well structure that type of behavior.
Yeah, that's another failure in it. So Sam's got next, but yeah, I think that
a failure?
That's one of the ways they failed is that not you, is that they you sort of have this layer up here where you're programming in interfaces, and you have this layer down here where you actually know what you're talking to, and so you don't use any interfaces, even if you're talking across objects, because you know that this emergency stop button is connected to this thing over here in that kind of machine. It makes it messy. Yes, Sam?
What immediately popped into my head was something like the decorator pattern from the Gang of Four book. They have a whole bunch of different patterns in there, and it's a lot similar to what Norm was saying about using composition instead. So.
All right. Any other comments or questions? Because I think that's the end of my slides. But what other questions or comments you've got, Adam?
Just back on the topic of when you reach a design fork, choosing an abstract class over an interface. I think about it more from a developer experience standpoint rather than a user experience. I'm not sure if we're talking about users in the case of us as programmers, but in any case, I think of, I'm not the first person to use this phrase, but I think of an interface being a contract. Where a HAL, like the guys from Test Track talked about yesterday, a HAL is a great example where if I have a team of developers building a bunch of different power supply drivers, I can define an interface that basically tells them your power supply device must implement all of these things in order to function like a power supply. If I find that that parent entity needs statefulness or needs a host of implementations in and of itself, which LabVIEW sort of splits the difference there with interfaces. You can have default implementations of the methods, but traditionally, that's kind of the deciding point for me is if I need state data and I want default implementations, I will generally trend towards an abstract class rather than an interface.
Yep, and I want to highlight one of the things you said about being a contract. I mean, that's one of the ideas that COM really pushes on its interfaces. So when you look at like Excel or Word or one of these older applications in its ActiveX interface, you'll see that they've changed or added versioned interfaces to how you control it as they've added features or made things easier to use, but they still keep all the old versions around so that if you are programming at version 1.0, your application will still work with this DLL that gets installed with Excel or Word, and if you have a newer version, you can be programming the 2.0 or 3.0 interface, and so on. So that's another way you can use interfaces to insulate yourself. All right, I am out of time. Thank you all very much. I hope it was interesting, at least.
A special thanks goes out to Kevin Shirey, Quentin Q. Aldridge, Mark Balla, and Jeff DeVore for their help in filming. And of course, this GDevCon NA 2023 wouldn't be possible without all of our sponsors. Thanks.